Just about us. The camera's yours.
Perfect. My name is Brian Bouters. I'm the product owner for Hosted Pulp, which is a service that's run at Red Hat. We use upstream Pulp to serve a variety of stakeholders, and we've been running it in production for about 2 years. It's very large, and let's get into some of the lessons we've learned over the last year. A year ago, I gave a similar talk, and so this is going to build on the previous one. It's going to have distinct content. So here's a look at our agenda. The AI made this slide, so that's why it's pretty. We're going to look at our database and uploading and authentication, some monitoring and log analysis, and also our push for self-service. Please feel free to raise your hand or unmute and ask questions. If you're watching this later, you can also ask questions in our chat or email me at my email on the first slide. So the database is definitely the most challenging component when you operate a really large Pulp installation. We run ours on top of Kubernetes, really on top of OpenShift. And so we have hundreds of pods, hundreds of workers, and lots of API and content pods as well. So this creates a whole bunch of SQL load. Right now, we have about 6 terabytes of SQL data. Pretty sure we're going to have to scale that up in the next couple days, actually. There's just an incredible amount of data of content units inside of here. It's one really large Pulp installation. By data count, I think it's probably maybe the largest, but anyways, we've had to increase the IOPS, the IOs per second, and the RDS instance size. So that's not the amount of data inside of RDS, which is the Amazon hosted Postgres database, which is called RDS. So over the last year, we've scaled that up in terms of the amount of capacity, not the size of the Postgres data, but the amount of, the machine that's basically operating the pSQL processes. So we've had to just basically make it larger and larger. You can only do that so far. We don't do any sharding today. I'm pretty sure in 2026, we're going to have to start doing sharding. So probably next year, I'll give a talk on sharding. But the other way that we're trying to win this game to manage this problem is to make improvements to the application. And the good news is that those improvements benefit pretty much all of our users. So there are 3 I want to tell you about real quickly. One of them is the repository version set calculation. So I don't want to get too deeply into the data model inside of Postgres, but if you want to say, hey, here's a repository version, what RPMs or Python wheels are inside of it, Pulp would have to compute that at runtime. And it actually has to compute it for every repository version in the whole history of the repository in order to calculate that very next one. So when you have a large amount of data and you have a lot of repo versions, it takes a really long time. So things that should take seconds on a small installation, on our installation, we're taking over 30 minutes, which is just totally just unworkable. So what happened here is big thanks to Jared for fixing this. Now, starting with Pulp 3.83, that set calculation is not recomputed at runtime. It's computed once and then saved, which is very efficient. And then that drops that runtime calculation right back down to something that's just reading right out of the table, which is very efficient. That was a huge pressure relief on our installation. So if you're running that version or newer, then you're already benefiting from that. Also the tasking load. So we have over 100 workers typically, and there's a lot of heavy database interaction. We couldn't really scale up more than 150 workers. We have goals to be able to scale our worker count a lot larger than that even. So, and some improvements have been made to the tasking system as well. So we haven't, done a full retest maybe in the past month or so. So these numbers are maybe a few months out of date, but there have been some improvements made to the efficiency of the workers as well. But regardless, one of the ways that we're really focusing on solving that problem is in a different way is to implement synchronous upload APIs. When you synchronously upload, and I think some other talks have referenced this as well, when you synchronously upload, say an RPM, you don't have to create a task when you do that. It just delivers the binary data to the server creates the RPM during the request response workflow, and there's no task actually generated. So this significantly dropped our tasking load. So we serve a variety of stakeholders, and some of them will upload like thousands of RPMs per hour. And so, if each of those RPMs becomes a task, that's a lot of tasks. By implementing sync APIs for upload, those aren't tasks anymore. So you can just think of that as like thousands of tasks that just never had to run, which, there's still some database interaction there, but it doesn't have to go through all the SQL load that pushing it through the tasking system would generate. And also, we don't have to scale up the number of workers, which in turn also generates more SQL load. So sync APIs are a great way to reduce your tasking load, which in turn helps solve and reduce the pressure on the database, which is what we did there. We did do this for, just a call out for RPM. We just added one for file. There's a sync upload for Python, and probably more to come in 2026. So we're also about to disable what's called touch for orphan cleanup. So the RDS tooling shows you what are called the top SQL queries, and it basically shows you opportunities for how you can reduce your SQL load. And I don't want to get too into the details here because just for the sake of time, but when you're running sync tasks, as the sync pipeline runs, it looks to see if content units are already in Pulp or whether it has to download and create them. And it can be minutes before those units are then associated with a new repository version. So there's a portion of time where if an orphan cleanup runs, that content unit could be deleted accidentally. And then when the sync pipeline goes to associate that existing unit, like an RPM, with the new repository version, it will fail because it thought it was there, and then it goes to associate it later. It's not there anymore because orphan cleaned it up. So what we do is we write these timestamps with this call called touch. And so if you're running a lot of sync tasks like our installation, it's just endlessly writing timestamps. I mean, it's overwhelmingly loading our database. So we haven't done this yet, but we're about to, so I wanted to talk about it here. We're just going to disable it. That's all we really can do in Pulp 3. And it's a better situation for our users to accept the occasional sync failure or be more discerning about when those users themselves dispatch orphan cleanup because they're in charge of the API calls. So we're just going to disable it. And we really have to do that because the SQL load that this aspect generates is just tremendous. I'm hoping for a full resolution in Pulp 4. I don't really want to get into like what that could be necessarily, but if you're interested in that, you can chat with us about it in the channel. So these are some of the ways that we manage our database. It's definitely our biggest component. A little bit more about upload performance. So this builds on the previous talk about sync APIs, but with a few more pieces of information. So here's a challenge in using. Here's a challenge that we ran into. So say you have to upload like 2,000 packages to a repository as fast as you can. So chunk uploads require reassembly, and they also create a task. This is what I was talking about in the previous slide. So that's a challenge. That's like 2,000 tasks. But as you add each of those units to a repository version, the tasking system doesn't do that all in one go. It creates, there's 2,000 tasks, and because they're all associated with a single repository, they all get linearized. This is a correctness requirement because you can't be creating, for one repository, multiple repository versions concurrently. And so by design, the challenge is that if you want to upload 2,000 packages, then you're going to have to run 2,000 tasks linearly. The units come in so fast to our installation that as fast as you can make the tasking system, they just come in faster. And so architecturally speaking, we're just kind of backed into a corner here. So we made the synchronous uploads. The way that solves the problem is, like I mentioned before, you upload the units without creating a task, and they're created as orphans, and then you can call a single add and remove call and reference those N orphans. And so that's great because now it's highly parallel. And there's no like linear architectural issue because there's a single task that creates the repository version for all 2,000 uploads. So our users love that. Everybody who uses it just is like, this is great. But then they also want to be able to upload really large files. And sometimes these come in over links that like network links that aren't super fast. And so they can, practically speaking, just take a large amount of time. So like in practice, we'll have 3 and 4 gig and larger single RPMs. We can debate whether those RPMs are a great idea to have or not. It's not really Pulp's position to say. I think they have good reasons, but let's just accept that these RPMs, for example, are really large. So what our goal was to enable up to 30-minute uploads. We had to change unicorn timeouts on Pulp. The setting, I'm not going to get deeply into the settings here, but basically like tune your unicorn to allow for large ones, tune your reverse proxies in front of Pulp to allow for large data to be uploaded. We disabled buffering on the reverse proxies, which I also refer to here as the gateway, in front of Pulp. Our particular, well, actually, let me say this first. So, one way to think about how you get large parallelization through upload workflows is to upload like N chunks of a single 4 gig RPM at once and upload all of those in parallel, and that's your parallelization. This architecture changes that so that you can still get really great parallelization. What you need to do, though, is just upload N RPMs concurrently instead of N chunks of 1 RPM. It's kind of all the same, really. But what isn't the same is the amount of complexity that our integrator's API code carries. If you do chunked uploads, you have to, not only do you have this like architectural tasking system issue, which is basically a non-starter, but you have to have your code break it up into chunks and upload the chunks and call a reassemble and then pull the tasking system. And the code implementation on the client integrator code is just a lot more complicated. So our users love this because they can just, use like a thread pool or multiprocessing or something to just really simply just say, yeah, just upload this one to Pulp. And I don't know if it takes 26 minutes, like, yeah, it's fine. And in practice, this is working really, really great. And our users love it. Their code stays simple and it's simple to think about, simple to debug, and that's great. Our deployment has what's called a web application firewall in front of it, also called the WAF. A lot of large services will do this. These are services like Akamai's WAF or their edge services or services like Cloudflare, for example. And they primarily provide things like denial of service detection and rate limiting and stuff like that. So we had to work really closely with the teams that run those systems here at Red Hat to get those timeouts set correctly. And one of the little gotchas that we ran into was when the reverse proxy in front of Pulp performs buffering, as it receives all of this data, the client submits all the data to the reverse proxy, and then it stores it all in memory, which is not great for the reverse proxy. And then it delivers all that data to Pulp, and then Pulp processes the binary data, turning it into, like, say, a 4 gig RPM, for example. And in turn, like, we primarily use S3 as our backend, so Pulp in turn then has to like push that data back out to S3. So it takes time, and then during that time, the connection between the client and the web application firewall is kind of silent, but it's open. And there are timeouts there as well, designed to prevent clients from kind of like tying up the WAF for long periods of time. And so disabling buffered overall on the reverse proxy was really a good idea because it reduces significantly the amount of memory that's needed to store kind of like it doesn't do store and forward anymore. It just kind of like continuously flows the data through it into Pulp. And it also keeps both sides of the connection, like the client to the web application firewall, and then the web application firewall to the gateway, and then the gateway to Pulp. Every piece of the connection is kind of continuously flowing data. So like you don't run into any long timeout issues. Every piece can see like, oh, this is still meaningfully being used. So disabling buffering was a very good idea for us. That's something that we learned. So authentication integration, we defer authentication entirely to the gateway in front of Pulp. We have a custom middleware which logs in our user. We receive the trusted user data as a header, and we interpret that. I talked about this last year, so I'm not going to kind of like go back over it. You can look at the talk some last year. But what's changed since last year was we dropped some of the types in the last 12 months. We're still in the process of kind of fully bringing this to fruition, but it's definitely underway. We dropped some types because they required a lot more human-to-human interaction to set up. And so we wanted to go basically with just simpler authentication types. So one of the things that we dropped is what's called OIDC. So OIDC is something that's built on top of OAuth 2. If this doesn't make any sense, as it didn't to me before I worked with this installation, then just think of it as your client has a secret and an identity, and it submits that to the gateway to get a short-lived token, and then you use that short-lived token to interact with the gateway. There were two issues that we ran into with OIDC support. Even though Red Hat really seems to like it, it just is not a good fit for our service in particular, so we're just not using it. Users in our database come in as just a UUID, and so we just don't have when we have some sort of a like operations issue and we're like, hey, what users do we like reach out to for this problem? We just don't have a way to know who they really are, and that's a practical problem for us. The other issue is that a lot of the client tools that we do need to support don't support that, and we're not in control of that. DNF doesn't do it, PIP doesn't do it, Podman doesn't do it. I'm not actually sure what does it. The Pulp CLI does it because we added it to Pulp CLI, but in hindsight, it's just not a great authentication type for us to use, so we're not going to do that. We're also dropping basic auth support for in-cluster requests. So basically, we're now pushing all traffic, or very soon we'll be completed with this activity, pushing all traffic through the gateway. This is what I mean when there's more human-to-human interaction. So like when other applications on the same OpenShift cluster, try to authenticate directly to us, we have to like pre-set up and send out pre-shared secrets. So let's get out of that business. And so we're no longer supporting in-cluster basic authentication. So what do we support? Just two ways. It's pretty simple. One is certificates. Everything supports certificates. They're great. And the other one is basic auth through the gateway. Basic auth is also what's the de facto standard for tools like Docker and Podman, for example. It's also supported by all the client tooling as well, even like DNF and PIP, because you can just put those basic auth credentials right into your URL string, and those tools have proper support for that. OTel monitoring. So we use a lot of open telemetry, OTel. These are the kinds of things that we have here, and I'm going to just show you some flashy dashboards here in a second, but I kind of group them into a couple areas. So one of them is API endpoint health. So we do latency and response code statistics per endpoint. We also look at memory consumption. Task and system health. So looking at our unblocked task counts. We actually do auto scaling. Great job to Deco de Brito for getting that working. To be able to dynamically scale our workers up and down based on the amount of unblocked tasks. The volume of tasks can change dramatically on like a minute-to-minute basis. So,
Brian, I'm going to interrupt just briefly here. It's 10 till, So you have 5 minutes,
Great.
and we can slop over a little beyond that if you need to.
Perfect. Thank you. And success and failure breakdowns, and also Pulp has immediate versus deferred tasks. So basically just a lot of those kinds of things. And content serving health. So like we want to understand our cache hit and miss rates. So we do that. We can also look at file sizes and types served by the CDN. The file sizes is interesting in particular because Pulp returns redirects. And so, the most basic open telemetry monitoring will just tell you the size of the redirect. But ultimately, we want to be able to gather data around the cost for things like S3 to serve that data via egress out to the internet. So like I issue you like a 70 byte redirect, but then you have to pay the bill to serve like 4 gigs out to the internet. But our installation can't see that directly. But Pulp knows how big the binary data is. And so we actually emit OTel metrics to gather what will be emitted so that you can run like cost reports and stuff like that. Couple other ones, database storage and health. So like this amount of storage space remaining, the number of domains. So we have like roughly 5,000 domains on our installation right now. So we make super heavy use of that. And also the binary data storage size per domain. So like any given domain can say like, how much is this costing me? For instance, storing this data at rest. I'm just gonna quickly hop over to some of these charts here that you can see in our Grafana instance. This you can see is the number of pod counts. This is the dynamic scaling happening here. This is like the latest 6 hours. Database sizes, memory consumption, API percentages, upload counts, waiting times. You can see this is the dynamic scaling at work right here. Like there's a backlog of tasks, like hundreds of them to run. Oh, we scale up, there's none. And you can kind of see how that works. Different types of artifacts served. Anyways, we've served, let's see, a little under 12,000 tasks in the last 6 hours today. We can see like breakdowns of different task types. So anyways, we really, really rely on this. And I hope to share more of this, these pre-built Grafana configs over the next year. If you really want access to them earlier than that, just reach out to us. One of the big challenges we had in this area has to do with the cardinality problem. There's some great YouTube talks about this. Go watch those. But the long and short of it is that all the data that OTel is run on is time series data. And it has dimensionality in the sense that each data point has a certain number of attributes attached to it. And those attributes kind of multiply as multiples. And so, if I have like 20 workers and each worker name is there, and then I have 50 endpoints, that's 20 times 50 time series data. And so every attribute you add significantly increases the cardinality of the data Prometheus has to store. We were right up against the limits in terms of what Prometheus is capable of doing. And so we reduced the bucket sizes. This is a feature you can see in Pulp Core to configure your OTel stuff. We reduced the metrics just down to the ones we really super duper care about. And we are probably going to re-architect our OTel to do more data transformation on what's called the OTel collector, which is the thing in between your application and Prometheus. So there's some more opportunities there, but I'd say the problem is like pretty well managed at this point. Log analysis, and then we're almost done for questions here. We make heavy use of log analysis. So some of those Grafana things that you saw are built on OTel metrics. Some of them are built on Grafana actually queries the logs themselves. So we really got an appreciation for using the right tool for the job. And looking backwards, it was kind of naive for us to think that OTel was the right tool for everything. So now we use a lot of both. Access logs, for example, like that's not a thing that you should use OTel for, that's for logs. Correlation IDs for tracking specific errors across the different components when all the logs are at the same place. Tasking health data, all that kind of stuff. So we use a lot of log analysis, and you should too. The last thing here is self-service everything. So increasingly over the last 12 months, more and more of our time is spent on onboarding. And so it's to the point where we're almost at capacity in terms of our people time. So we've got to move more to self-service. So here's some of the things we've done to do that. One is the domain creation. I mentioned this problem last year. We didn't have a solution yet, but we do now. So our business model is we provide a starter bucket for users, like an S3 bucket to store their data in. And then once they hit a certain threshold, we require them to provide their own bucket. So because we have access to our starter bucket and they don't, and you need to provide that that access at domain creation time, people would have to come to us to create their domain. That's not scalable when you have 5,000 domains. So we have a special endpoint that we carry in our installation, which will auto configure your starter bucket. Also domain authorization. I mentioned last year about how our authorization works. It's at the domain level. You can learn more about it from the previous talk. But what we've done since then is we redeployed the Django admin and we integrated it with the SSO at Red Hat, which was pretty easy to do. Just kind of interprets the header data that we get from it. And you can now, in our installation, look at your domains and your domain authorization records, and it's group and team based. And so now, previously our stakeholders had to come to us like, oh, we have a new person on the team and so left. Can you update their access? So we had to get out of that business entirely. So now they can do all of this in a self-service way through this Django admin site. This is not something that's in the upstream because it's very specific to our deployment, but it was not that hard to make. Props to Deco DeBrito again for kind of leading this effort. And that's a way that we really were able to take a whole bunch of self-service day-to-day work and just turn it over to our users directly. And also the last one here is log analysis, which is we make our logs directly available to all of our stakeholders, so they don't have to come and ask us for reports. And also our Grafana instance, they can also access all that directly. So self-service is one of our themes for this year. And that's all I got. Feel free to reach out to me with questions and you can ask some or comment now.
Great talk, Brian. We have time for maybe one question before we hit the top of the hour. We're a little over. Does anybody have anything, or do you want to just hit us up? Ruben, go ahead.
Hi, thanks for the talk. I thought it was cool. And I would actually have liked if you did even a longer talk. What I wanted to ask was, will the dashboards that you have internally be open sourced or partially be open sourced?
Yes, that is our goal. And it's kind of just a time and priorities issue. And if you'd like to, one of the things that would be helpful in getting there is if we can collaborate on Matrix some. I'm BM Bouter on there. And I'd like to take just a little piece, the most valuable piece. And that's what I want to hear from you and other users. What's the most basic part that we should put out there? And I think the plan is that we're going to try to publish them through Grafana's community, which then if you're in your Grafana instance, you can just import them directly from there.
Yeah, I mean, the configuration for the dashboards actually lives on GitHub. And I just put in chat a link to it.
Outstanding. I was just about to drop that there.
But I don't know how useful that is to you without having your OTel collector and Prometheus already set up. But there's no documentation. This is just a config file. And
yeah, but what I can say is there's intent, so reach out to us. Great.
Yeah, definitely intent for sure.
Okay, yeah, sounds awesome.
Outstanding. All right, I'm going to cut us off here because we have 20 seconds before it's Jeffrey's turn. Thank you so much for the talk, Brian. That was outstanding. Let me stop the recording here.